2n, right? This is a fact. A fact which is a little bit strange because this has never happened before, but it's just a true that there are precisely 2n terms here inside the brackets. Okay, so this isn't, I don't want this to become one of these things where you just look at one number and you're like, oh, this is probably this, and you just like write some crap down. You gotta really like fully process what's going on, and for that possibly we should be making a picture. What is the function that we appear to be evaluating sample points at? Root x, and that is true. But from where to where? Well, it seems as if I'm plugging in that and then skipping by 1 over n, I'm skipping by 1 over again. And so like my first rectangle will be 1 over n, my next one will be 2 over n, my next one will be 3 over n. But then something kind of strange happens, strange because it's never happened before. I don't stop at n over n. I keep going, well past n over n and all the way to 2n over n. So I actually have like 2n rectangles this time. Does that change anything? Since n's going to infinity? Not really. No, it doesn't change. But it does tell you that in fact, what integral is this? Integral from 0 to 2 of root x. And prior to yesterday, we would have had no way to do that. Well, not no way, but it would have been hard. But now, armed with the fundamental theorem of calculus, this just becomes easy, right? How do I now take the integral from 0 to 2 of root x? Well, I go, all right, I'm going to write this in anti-differentiation friendly form because I'm prepared to do some anti-differentiation. Fundamental theorem of calculus says I can do an integral as long as I know an antiderivative. Do you know an antiderivative of x to the 1/2?
Yeah.
What is it? Yeah, you go up a power to 3/2 and you divide by 3/2. So this 2/3 x to the 3/2 evaluated at 2 and 0. This is just some FTC happening right now, the useful part. Yeah? So when you plug in 2, what do you get?
2/3 root 8.
2/3 root 8, yeah. 2 to the 3/2 is like root 8 or 2 root 2. And so this is 2/3 times 2 root 2. And so this final answer is like 4 root 2 over 3. And that's something I didn't know how to do until yesterday because I don't have summation formulas. I think I did that right, yeah?
Yeah. I just messed up.
How are we doing? Okay, let's skip number 3 and go to number 4. Number 4 is hard for like even a different reason.
Yeah.
Go.
Out of the integral. 4 cubed is 64.
Question.
128 over. What? No, just like take the cube out. Wait, it's 4 times that. So just 4 times 256 over.
And this should be like, this next one is 6. That's like really not really clear. It's not like exponential, it's like skipping that. Yeah, skip the 3 is like easy, I want to do number 4.
Does 5 even exist?
No, I mean, that's like a typo slash just decided to leave it there for fun.
No, like.
No, I heard you, Micho, We're not doing number 5 now, we're doing number 4. Good. I love this guy.
Don't worry about it.
Okay, what's going on?
First you have to take out 2 squared to make it like more easily equal form.
So you don't have to, you can.
Kind of.
You can, but you don't have to. I'm going to not do it that way, although you could. What appears to be going on here? Just talk to me, share your feelings.
Some kind of x squared or
each term.
Okay, so I like that some kind of x squared. If we commit to thinking of this function, the underlying function as x squared, let's just suppose we commit to that, right? We're not bound to that, but let's just decide. Then that brings some clarity as to what's going on, and I can suddenly sort of start making a picture of this situation. Because what's the first number that I'm plugging into x squared? 2 over n, is that what you mean?
oh yeah.
Yeah, 2 over n is the first number that I'm plugging in. And what's the next number that I'm plugging in? 4 over n, and the next number I'm plugging in you know, 6 over n, etc. Okay, maybe a next question to ask is, how many terms are inside this bracket? That's worth mentioning. 4n terms, that's pretty crazy. And what's the last one? What's the last rectangle that I appear to be plugging into this function? Like 8n over n. And so this appears to be some kind of like integral from 0 to 8, but what's a little bit wrong?
There's only 4 in 2.
The width is a little bit wrong. Yeah, Annika says, what is the delta x for each of these? If I interpret it this way. This is like 2, this is like, yeah, the delta x is 2 over n here, right? Each of my rectangles is 2 over n wide, and yet this is like a little bit wrong. Okay, so one thing you can do is just throw in a 2 over 2, and now it's working out perfectly, right? Now this 2 over, now it's like a Riemann sum, because the 2 over n is in fact the width of these rectangles. And therefore, what is this? 2 times the integral from 0 to 8 of x squared. This is not the only way to do it, but this is a way. Do you see what I did? I multiplied by 2 on the inside and then 2 on the outside. That's allowed, right? It's like a limit. So. Now delta x is 2 over n.
Wait, isn't it 2 and then 1/2? Yeah.
Oh boy! That was embarrassing. Good thing you didn't do it yet. Yeah, you multiply by 2, you cancel with a 1/2. Good, sorry for being totally, really dumb for about 30 seconds. So anyway, this is the answer. And then when you go to do it, you get 1/2 times x cubed over 3, but then evaluated at 8 and 0. And what you get is 8 cubed, which is like 2 to the 9th. But then you're dividing by that, so it's like 2 to the 8th. So it's like 512 over 3. I believe that is correct. Someone will correct me if I'm wrong. There's another way to do this problem. Do it your way. If you don't like this way, you should also get 512 over 3. Good! Woo!
256 over 3.
256 over 3 because I did that math again. 2 to the 8th is in fact 256. So I had the 2 to the 8th part right, but I had my number wrong. Good job! Multiple mistakes at the end there. Woo! Goodbye, people watching.